afternoon, everyone. My name is David, and my supervisor is Sarkis Kaprelan. And today I'm going to present the Robotic Piano Hand. Where does the motivation come from? It comes from creating a robotic hand that is more compact and natural and has natural movement of limbs, of the fingers, which is not the case in the market nowadays. They usually have big hands, and the motors are in the arm part. It will be a prototype for a future prosthetic, so people who don't have only the hand part will be able to use it as a prosthetic. And of course, as it's gonna stay in AUA, it's gonna be for educational purposes for future engineers. So what are robotic hands? Robotic hands are effectors and effectors are mechanical devices designed to mimic the functionality and movements of human hand. They usually, in manufacturing fields, they are usually attached to robotic arms, which allows for better movements. So initially, I had two versions in my head how it's gonna be. One is with gears, using gears for each of the finger connections to move them. And the other one is motors and strings. So basically you attach a motor to a string and then attach the string to the end of your finger phalanx. And when the motor rotates, the phalanx stretches, flexes, and that's how the movement goes. So the method was very simple, like I described. We're gonna have input from the computer. It's gonna go to the microcontroller, which is gonna control the motor. Then the string controls the phalanx, and movement happens. So what I had to do? First, design a 3D model. So 5 sets of free phalanx and the palm. The first phalanx, the tip, you can see its models. The second phalanx, which attaches to the tip. The third phalanx, which is basically the second phalanx, but just a little bit longer, as our human hands have. The finger to palm connector. This is a special thing to allow movement in right and left directions for the finger to be more allow more dexterity. And the palm. This is actually the fourth iteration of the palm. First, it was very plain, but after 3D printing it, I broke it and understood that it's not gonna be reliable and pretty. So I changed it to this one, which allows more curves, which has more curves like our hands do. And the angle of the thumb is correct with angle of the thumb we have, we move it. And the final design is this. We connect all the pieces using bearings. So the parts were 3D printed with ABS, as Mona mentioned, because it ensures the highest temperature resistance and durability. So when it's gonna be a prosthetic, people won't worry about temperature very much outside. So we have to use motors, microcontroller, and strings. So the motor, I chose a small and fast servo motor to allow dexter movement, but controlled. So Emax ES3301 allows 0.10 seconds per 60 degrees speed at 6 volts, and its dimensions are very small. Yeah, you can see it here. An Arduino Nano microcontroller, and a non-stretchable string to allow the movement of the fingers, which is a nylon fishing line because it's very affordable and there's a bunch of it. So I had to connect the strings to finger tip and to the motors. How to do that? First connect the string to the finger tip by tying a knot on it. Then super glue the other end to the motor. So the power source, I use two 3.7 volts lithium ion based batteries with a buck converter to provide exactly 6 volts, which is the maximum allowance for the motors. And all assembled with my two fingers stuck with each other 2 times. We got the result here, you can see it. The coding. So the hand has 2 operational ways. First is moving the fingers with keyboard keys gradually and control them. And the second one is performing predefined motions or safe gestures. Future work maybe aesthetically improve this model because it looks very messy right now. Integrating touch and position sensors for better control and overall better movement of fingers. Changing Arduino with a better microcontroller because Arduinos usually are not as fast as other high-tech microcontrollers, which is required for fast movements of fingers. Maybe changing the motors, maybe finding or inventing smaller ones to allow more space in the hand, to allow more motors to be placed in the hand and thus having more free movement of fingers. Yeah, which I said. I want to especially thank my supervisor, Sarkis Kaprelan, who helped me a lot during the project, and all the engineering students who have assisted me a lot during the project with their ideas and maybe physical help. So, yes, that's it. Thank you.
Was more ideas or physical help?
Physical help. It was like connecting the strings to the motors and super glue them.
What's the secret behind the piano?
Piano, yeah, I forgot to mention it. So initially it had to play a piano to prove its movement abilities, but we tried it and apparently the force wasn't enough to push the piano keys. Yeah, and we had no time to get another motors. So, yeah, that was it.
Spreading on the palm doesn't work, right? You haven't done the palm spreading. So
No, it's stationary. Yeah, it doesn't move.
So if I can build on the piano question, your last slide had some future directions. And the second one says integrating touch and position sensors for better control.
Yeah.
Can you tell me what you imagine that could be or should be?
Okay, so touch sensors may allow microcontroller to decide whether to push the material more or is it already holding something or touching something. And position sensors are useful for calibration of motors if something goes wrong. And basically that.
So that's, I think, relevant generally speaking. Did you just answer my question with a piano in mind? Or is this about playing piano as well? Or
No, not only about piano. It's not only about piano, it's about being a future prosthetic. For example, you're someone who's keen on piano, but you don't have one hand.
Yeah, no, I got that.
But you have to use...
I'm wondering in terms of specifically about playing piano, there's a lot of research on proprioception of humans, and in tasks like this, how much of this is purely feed forward versus is let's say a musician actually getting feedback and adjusting, or is it auditory, or is it? I'm just curious when you wrote that,
Yeah.
how much of that had to do with actual, let's say,
Piano
tactile
key.
sensing and or control versus is the feedback, if relevant, coming from anything else? You
No.
meant this in a very general sense. What is a touch sensor? What is a position sensor?
Yes, I meant it in a very general way.
Yeah.
Nothing specific about piano.
Okay, thank you.